Have you ever wondered what powers the electricity that lights up your home? It's all down to a tiny particle called an electron. These elusive little entities, invisible to the naked eye, are the unsung heroes of the modern world, powering everything from your smartphone to your refrigerator. Electrons are integral components of atoms, the microscopic building blocks that make up everything in the universe. They orbit the nucleus of an atom, constantly in motion, and it's this movement that sparks the phenomenon we call electricity. Imagine electrons as a bustling crowd in a city, each individual contributing to the energy and dynamism of the place. Without them, the city, or in our case the atom, would be lifeless. Their role extends beyond just electricity generation. They're involved in chemical reactions, magnetic fields, and even light emission. So, electrons are tiny particles that play a big role in our lives, but what exactly are they? To understand electrons, we first need to journey into the heart of an atom. Imagine an atom as a miniature solar system. At the very core or nucleus, you'd find protons and neutrons. These particles are much like the sun in our solar system, central, massive, and indeed, quite influential. But let's shift our gaze to the outskirts of this atomic universe. Here in orbit around the nucleus, we find the stars of our show, the electrons. Electrons are subatomic particles, each carrying a negative charge. Just like planets orbiting the sun, electrons orbit the nucleus of an atom in paths called shells or energy levels. These shells are like concentric circles, each further from the nucleus than the last. The closer an electron is to the nucleus, the lower its energy, and the more tightly it's held in place. These tiny, negatively charged particles play an important role in the atom's identity and behavior. They determine how an atom will interact with other atoms, ultimately leading to the formation of molecules and compounds. In other words, they're the architects of chemical reactions. But electrons are more than just architects. They're also the powerhouses of the atom. They carry what's known as potential energy, energy that can be released under the right conditions. This energy can be harnessed to power our homes, our cars, and even our bodies. The number of electrons in an atom also determines the element's place in the periodic table. For instance, an atom with 1 electron is hydrogen, while an atom with 2 electrons is helium. It's all about the electrons. Yet despite their importance, electrons are surprisingly elusive. Their exact position at any given moment is uncertain, a concept known as the Heisenberg uncertainty principle. Instead of pinpoint locations, we have to talk about probabilities and electron clouds. So, electrons are negatively charged particles that inhabit the outskirts of an atom, but what happens when they move? Electrons don't like to stay put. They're always on the move, and this movement has significant consequences. Now let's delve into how this electron movement leads to something we use every day: electricity. Picture a metal wire crammed full of atoms. Each atom holds onto its electrons, but not too tightly. The electrons are free to move about, and this is the key to how electricity works. Here's where things get interesting. When we apply a force to the wire, such as a battery or generator, it pushes the electrons, creating a flow. This flow of electrons is what we call an electric current. But how does this flow occur? Well, electrons, being negatively charged, are naturally attracted to the positive end of the battery and repelled by the negative end. This creates a flow from the negative to the positive end of the wire. It's like a game of tag where the electrons are always trying to move towards the positive and away from the negative. Now this might sound a bit counterintuitive. After all, we often hear that electricity flows from positive to negative. However, this is a historical convention. In reality, it's the electrons that are doing the moving, and they're always trying to get away from the negative and towards the positive. But that's not the end of the story. This stream of electrons doesn't just flow aimlessly, it's harnessed to do work. Think about it. When you flip a switch, a light turns on. When you press a button, your computer comes to life. All of these devices work by controlling the flow of electrons. They take the energy of the moving electrons and convert it into light, heat, or motion. So, the movement of electrons is pretty important. It's the power behind our modern world, lighting up our homes, powering our devices, and making our lives more comfortable and convenient. The movement of electrons powers our world, but how can we manipulate these tiny particles? Scientists have found ingenious ways to manipulate electrons, leading to incredible technological advancements. These tiny particles, which we've come to understand are so critical to our existence, are also the driving force behind the technology we use every day. Consider the generation of electricity. It's all about getting electrons to move from one place to another. When we burn coal or natural gas, or when we harness the power of the wind or the sun, we're essentially creating conditions that encourage electrons to flow. This flow of electrons is what we call an electric current. Now let's think about light-emitting diodes, or LEDs. These clever devices use a principle called electroluminescence. When an electric current passes through an LED, it excites the electrons within the semiconductor material. As these excited electrons return to their normal state, they emit photons, which we perceive as light. Then there are transistors, the building blocks of all modern electronics. In a transistor, a small electric current is used to control a larger one. This is achieved by manipulating the behavior of electrons, allowing us to switch electrical signals on and off, or amplify them. And let's not forget about magnetic storage devices like hard drives. They work by changing the direction of magnetization of certain areas on a disk, which is done by controlling the spin of electrons. So you see, understanding and controlling the behavior of electrons has been key to the development of many technologies that we take for granted today, from the electricity that powers our homes, to the light bulbs that illuminate our nights, to the devices that keep us connected to the world around us. So, by understanding and manipulating electrons, we've been able to power our world and advance technology in unimaginable ways. Electrons may be tiny, but their influence is immense. We've journeyed together through the enigmatic world of these subatomic particles, unveiling their nature, behavior, and integral role in the universe. We started by unraveling the mystery of what electrons are, negatively charged particles that orbit the nucleus of an atom. We then explored how these particles are always on the move, creating an electric current that powers our world. We delved into the fascinating realm of manipulating electrons, touching upon the groundbreaking science behind technologies like semiconductors and superconductors. These manipulations are not just theoretical exercises, they are the bedrock of our modern life, influencing everything from the functioning of our electronic devices to the transmission of information across vast distances. Electrons, though minuscule, are mighty. Their ceaseless motion and charge are the lifeblood of our technologically driven world. Next time you switch on a light or charge your phone, remember the humble electron, the tiny particle with a massive impact.